All right, doing a little bit of properties of algebra today. Three big properties: the associative properties, the commutative properties, and the distributive property. We're probably the most familiar with the distributive property already, right? But associative property, in a nutshell, is just this. It's like how you group things together. Associative sounds like the word associate, right? And it's like the old common thing at a school is like, hey, who are you hanging out with? Especially like at lunch, you know? It's like, who are we sitting with at lunch? Who do I associate with? Like, they're kind of like friends. And here in a math class, the friends hang out in parentheses. Like, you see here, A and B are associating together, and C's just like not invited to their little like lunch table in that situation. But then all of a sudden, oh, no, B and C want to like hang out together, and A's not. So like instead of using like letters, which people aren't that familiar with, if you want to put some numbers down, you're welcome to. But the cool thing is, it doesn't matter who you group together when you're doing addition or subtraction. There is no such thing as the associative property of subtraction. Subtraction is just addition with negative numbers, right? You know, so like addition is just, takes care of it all. But it doesn't matter if you do 6 plus 3, which is 9 plus 7, you get 15 back. If you do 6 plus 10, maybe if I get my math right today, it's 16. If you do 6 plus 10, which is 16, it doesn't matter how the grouping symbols are at. The grouping symbols can happen either which way. And the same thing happens with multiplication. A times B first, and then you'd bring C into the mix, like 2 times 8. Then times 10 is going to give you the same thing, right? So associative property, the simple way to look at it is there were some grouping symbols. The commutative property, hey, I'm going to ask you this. If you heard that someone commutes to work every morning, what does that mean to you? Tell your neighbor, what does that mean if someone commutes to work? Basically, like they travel, you know what I mean? They got to travel, right? Commutative means things are going to move around. 2 plus 5 is the same thing as 5 plus 2. But do you see how, like, they moved around? 2 was on the left, 5 was on the right. Now 5 is on the left, 2 is on the right. So it's so common with multiplication. Is 3 times 4 the same thing as 4 times 3? You know, it doesn't matter what order you multiply them in. It doesn't matter what order you add them in. There is no commutative property of subtraction. You got to watch your negative symbols on that, but the order that things do happens, they commute around. And then, of course, the last one is the distributive property. Are you guys cool that if you have like a number outside of parentheses, it can be multiplied through in that case, right? So let's dive in and do some recognizing. Let's just see which property is which here. First, is it the distributive property, the one that you're the most familiar with, right? Did they take a number and like multiply it through the parentheses or anything like that? Nope. So it's got to be either the commutative property or the associative property. I look for groups. Was there some grouping symbols at all? Did you see parentheses at all? So this one is most likely the commutative property. Did things move from one way to the other? Like the 3A was on the left and the 2 was on the right? Cool. So it is in the commutative category. Question: commutative property of addition or commutative property of multiplication? What were they doing? Adding or multiplying? Adding. So here's how we'll abbreviate it. You don't get to abbreviate the word commutative, right? That's the vocab word that I care about. If you want to abbreviate property, you can. And if you want to abbreviate addition, I need you to put ADD. Don't put plus. I don't like it. You know, put ADD for addition. Cool. So we can abbreviate it to commutative. It's got to be spelled right. Yes, on your homework program, it's already spelled for you. We got a quiz next time. We got to spell the words correctly. So commutative property of addition. Next guy, it's got parentheses involved with it, right? So it is either the distributive property, where they took a number and multiplied it through the parentheses, or some sort of like associative property. So here's what I look at. So if it's got parentheses on both sides, there's no way it's the distributive property. Because the distributive property, once you distribute, the parentheses disappear. You know what I mean? It's just like, okay, we've used up the parentheses. So it's got to be some sort of associative property. And do you see how 3 and 5 were hanging out together in these groups? And now it's 5 and 2. But the order of the numbers never changed. It went 3, 5, 2, 3, 5, 2. What moved was the grouping symbols, right? The grouping symbols moved. So that is the associative property of what? Multiplication or addition? Yeah, so spell out the word associative. You can abbreviate property as prop, and then we'll abbreviate multiplication as M-U-L-T. M-U-L-T. And then I'll let you and your neighbor discuss on number 3, which one do you think it is? Get yourself into a category, distributive, associative, commutative, right? And then is it addition or multiplication if you're in one of those? And how do you feel about the commutative property of multiplication? Commutative property of multiplication. And then the last guy right here, there is definitely groups. There are groups on both sides. The groups move spots. You see the 9, the 3, the 7, the 9, the 3, the 7 are in the same order both times, right? The groups move, so that is an associative property of addition in this case, due to the fact that they were doing all kinds of adding. All right, so those were our bland old properties. Let's do the distributive property. And again, don't work too far ahead of me. I could care less if you draw these arrows. Some people like to draw the arrows. I don't need you to draw the arrows, right? But what's 3 times x, baby? 3x plus 3 times 4, which is 12. And then I look to see if there's any like terms, if I can combine them. Like, this dude has x's with it. Are you with me on that? Does this dude have any x's with it? So I cannot combine those together. Those are not like terms. So distribute the 7 through the parentheses. 7 times y is 7y. And then I just kind of like bring the minus down, and 7 times 3 is 21. And then you just got to look to see if there's any like terms, which there are not. So you and your neighbor get 7 done and get 8 done, and then we'll talk after that. How do you feel about those guys? Let's get into more advanced. We've got the scary dude right here that people don't like, the fractions. I've got a shortcut. I've got a cheat code on these. It doesn't work every time, but it works most of the time, because I don't really look at those as fractions. I look at that as like 1 divided by 4. And in other words, that's like a divide by 4. Are you guys okay with that? And I look at these dudes, and I love these numbers right here. I know there's an X with one of them, but I love those numbers. Do those green numbers, are they multiples of 4? Yes or no? So here's how I talk myself through it. How many times does this green number go into that pink number? How many times does 4 go into 4? Once. Then I take my result, which was 1, times the numerator. I got to take it times 1 again. 1 times 1 is 1. Are you with me on that? So I'm going to be down with 1 for my number. But there's an x with it. Do you need that 1 in front of the x? No, you do not, right? You can have it. You don't need it. Cool? Then this is a positive, this is a positive, so I'm going to put a positive. And then I start the process all over again. How many times does the green number go into the pink number? How many, backwards. How many times does the pink number go into the green number? How many times does 4 go into 12? 3 times. Then take that times the numerator. You see that you get a 3 back in that situation. Fractions really aren't that bad, especially when the numbers go into it. So I kind of set that up. You see that these green numbers right here are multiples of that pink number, which is the denominator in that case. So, sweet. I'll do this one with us. How many times does 3 go into 6? 2 times. Take that times the numerator, and I'm left with 2x. Plus, how many times does 3 go into 24? It's cool if you got to punch it in. It's like 24 divided by 3, you know. Like, how much is that? 8. And then we take that times the numerator and get ourselves an 8 back. But in both of those, the numerator of those guys were a 1, right? So there wasn't much to do after the fact. You just saw how many times does it go in it. You see here, boom, boom, we've got different numerators besides 1. Who cares? Are these green numbers, boom, boom, multiples of the denominator? Is 14 and 21 multiples of 7? So here's how we'll roll. How many times does 7 go into 14? Twice. Now take that times this numerator. 2 times 2 is how much? 4. And then there'll be an x with it. And who'd have thought you could take 2/7 times 14 without a calculator that fast, just by knowing that if 7 goes into 14, cool, how many times? Then take it times this. So let's do that again. How many times does 7 go into 21? 3 times. Take that times the numerator. What's 3 times 2? 6. Cool. So let's try that one more time. How many times does 8 go into 8? Once. Take that times the numerator. And then I'll let you try the last nugget on that situation. 8 goes into 16 twice, times the numerator, 6. Hey man, it doesn't always work that way, you know. It's like, okay, that's not going to be very nice, right? That's not going to come out nice. Why? This number is not a multiple of that number. This number is not a multiple of that number. We'll cross that bridge another day, right? But just kind of getting the basics of, if you can see a little shortcut with some fractions, we'll be all right. Okay, just a few more and we're done. Uh-oh, all kinds of stuff that we got to do. But you see we have a little like separator right here. It's like, okay, there's some other junk down to the side. We'll do them one at a time. Can you distribute that 2 through that green situation right there? Get that done with a neighbor. How do you feel about 10x plus 12? Right? Are we cool with that? And now I'm going to distribute, instead of distributing the 4, you got to think of him as a negative 4, right? He's not just a 4, he's a negative 4. So I'm going to distribute negative 4 through the parentheses. And here's where the sign errors come in, right? So let's watch ourselves. What's negative 4 times x? There we go. And then, of course, we all know 4 times 2 is 8. I want to know what negative 4 times negative 2. Plus 8. And I guarantee you, I would say with 100% accuracy, if I asked any of you what's a negative times a negative, you would say positive. If you can get your brain to ask yourself that, it's like, okay, I got a negative times a negative. You'll know that it's a positive in that case. Uh-oh, are there like terms in this guy? Here's some x's. Are you with me? We've got 10x and like a negative 4x, right? And then here's some constants. There's no equal sign, so I just got to like add them together. So if I had 10 x's and then I lost 4 x's, how many total x's is that, baby? 6x. And then the 12 and the 8 are like terms, so how about we add those together and get a 20, and we either like box or circle our answer in that guy. Cool. All right, so let's rock this dude. Let's distribute the 9 through. And then distribute the 3 through. And then look for any like terms. You can add all your y's together. You can add all your constants together. Feel free to use a calculator if you need to. It's all good in the neighborhood. How many total y's do you have after you've just like combined like terms? 30 y's. And then 18 take away 12. How much is that, baby? 6. Are we cool with that? All right, let's get into some new dudes real quick. Let's distribute the 6 through. Now we got to go to 3 little nuggets right here, 3 different terms. So that would be 12x squared, right? You can only take numbers times numbers, x's times x's, y's times y's, etc. So the 6 times the 2 is 12, and the x squared just comes down with it, plus 18 x's, right? Take away 6. Let's time it out. Before we go further, are there any like terms out of those 3 guys right there? Like terms have to have the exact same letters raised to the exact same powers. And we can all see they're using x's. Are you with me on that? But isn't the green one x to the first power, and the blue one is x to the second power? Are you with me? Those are not actually like terms. You cannot add those together, right? X squareds are different than x's. Are we okay with that? Even though they're using the same letters. So can't add those together. What do you want to distribute through the parentheses on this guy? What number is this right here? It's not just a 1, it's a what? Negative 1. So we'll distribute the negative 1 through. That would give you a minus 7x squared Ooh, a negative 1 times a negative 3x is a positive 3x. And then a negative 1 times a positive 4 is a minus 4. With me on distributing the negative 1 through. Then we can put all our x squareds together. I kind of have them color coordinated for us, right? I'm just that kind of dude, right? I have 12x squared, take away 7x squareds. How many total x squareds would that be? 5x squareds, right? The exponents don't change or anything like that. You're just adding up all your x squareds. Here's 12 of them. I took away 7 of them, so now I have 5 of them, right? 18x's plus 3x's is 21x's. Are we okay with that? And then negative 6 and a negative 4, not 10, because that would be like, it's not a negative minus a negative. Like, it's still going to be negative. If I lost 6 yards in football and then I lost 4 more yards, haven't I lost 10 total yards in that one? So it's minus 10. Are we okay with that? Cool. You and a neighbor get the last one of the day done, please. See how we do. Are you good with my distribution? I have distributed. Did I do all that right? Cool. Are there any like terms? Yeah. Those are called constants. Like if you don't have a variable, you know why they're called variables? Because they can vary. You know, it's like, what's x? Oh, I don't know. It could be 1. It could be 2. It varies. But the constants stay the same. Like 6 is a constant. 4 is a constant. So I can add those together, right? I like to put stuff in what's called like the proper order. You know, it's called standard form. So I list all constants last. I usually, sorry, that should be a 24. I put all the stuff with x's first, then y's, and then the constants last. You see, like the 10x and the minus 24y are not the same letter. They're not like terms. You feel okay with that? Cool, man. That's it.